Good morning, students. Today I'm going to take solved problems. Okay, students. Before that, just I am recalling the definition of Doppler effect. Okay, students. Right? Okay. Definition of Doppler effect. Whenever there is a relative motion between a source and a listener. Yes, so just imagine. So source is train horn sound, listener means yourself. So just imagine. Okay, so whenever there is a relative motion between a source and the listener, the frequency of sound heard by the listener is different from the original frequency of sound emitted by the source. So there is a difference in frequency of sound. Yes, so this is known as which effect? Doppler effect. Which effect? Doppler effect. Okay, students. So there is a apparent frequency change. There is apparent frequency change is nothing but which one? Doppler effect. Okay, students. Right. Now come to the fourth problem. Solve problems. Students, we already discussed 3 problems. Okay, that's why we start with fourth problem. Okay, students. Okay, see this. A source and a listener are both moving towards each other with the speed v by 10, right? With the speed v by 10, where v is the speed of sound. Where v is the speed of sound. Okay, if the frequency of the note emitted by the source is f, so the source emitted frequency is f. Okay, next, what will be the frequency heard by the listener? So what will be the frequency heard by the listener? Okay, students, right? So from this one there is a solution. What is the solution? See this. When source and listener are both moving towards each other. So from the question, listener and the source are moving towards each other, and the apparent frequencies. What is the apparent frequency? See, the apparent frequency is the formula in the table. Okay, so from the table I'm taking n dash, which is equal to n dash is the frequency, apparent frequency, and n dash, which is equal to v plus vl divided by v minus vs, l for listener, s for source, into n. Okay, but from the question, both frequencies are both velocities are v by 10. The velocity of sound from the listener and the source both are equal to v by 10. V by 10. So that's why VL is equal to Vs equal to V by 10. Okay, right. Just I am substituting the values in this equation. So therefore, see this n dash, which is equal to V plus, instead of VL I am taking V by 10 and divide by V minus V by 10 into n. So here I am simplifying from this one, 10V plus V divided by 10. So 10V minus V divided by 10 into n. Okay, students, I am taking LCM and I am simplifying. Okay, right. So from that, yes, n dash, which is equal to, so 10 plus v, 11v. So 11v divided by 10 divide by 9v, 10v minus 1, 9v. So 9v divided by 10. So what will cancel? V cancel, 10 cancel, into n. So what will come? 11 by 9 will come into n. Yes, so therefore then 11 by 9 value, which is equal to what? 1.22 n. So the apparent frequency is 1.22 n. Okay students, it is easy, no? Yes or no? Yes. Yes, this is a simple problem. Okay students, right? Okay, shall we go to the next problem? Yes, right. See the fifth problem. At what speed should a source of sound move away from a stationary observer? At what speed should a source of sound move away from a stationary observer so that the observer find the apparent frequency equal to half of the original frequency? This is the frequency, right? See, it is apparent frequency equal to half. Half means what? 1 by 2. So half of the original frequency. Half of its original frequency. Okay students, right? Okay, right. Is solution. So therefore the frequency is half of original frequency. That's why 1 by 2 into n. 1 by 2 into n. Okay, if the source is moving away from the stationary listener. So from the question, if the source is moving away from the stationary listener, then the apparent frequency is, and the apparent frequency is, so what is that formula? N dash is equal to V divided by V plus Vs into N. Okay, students, but this frequency is half of the natural frequency. That's why instead of n dash I'm taking 1 by 2 into n by 2. So what is cancel? First this n and this n cancel. Okay students, n cancel, and so what will come? 1 by 2 this side and v divided by v will plus vs this side. Now I'm going to take v plus vs go to this side. What will come? V plus vs. And 1 by 2 go to this side. What will come? Multiplication, therefore 2v. Right. So if I'm taking vs alone, come to this side. This v go to this side. 2v minus v. So 2v minus v. Yes. So what will come? 1v. That is v. Therefore vs is equal to v. The velocity of s sound from the source which is equal to velocity in air, velocity of sound in air. Okay students, right? Do you understand? Okay students, okay. Next, conditions for no Doppler effect. There are 4 conditions given in our book. Conditions for no Doppler effect. Say this: under the following circumstances, there will be no Doppler effect, and the apparent frequency as heard by the listener will be the same as the source frequency. Okay students, see, when source S and listener L both are at rest. So both are at rest, there is no Doppler effect. Okay, next, when source and listener moves in such a way the distance between them remains constant. So both are moving in the same constant speed. Yes, there is no Doppler effect. Okay students, there is no Doppler effect. Okay, the next point is when source S and the listener L are moving in mutually perpendicular direction. What is mutual perpendicular direction? Yes, both are moving perpendicular to each other. That means 90 degree. Suppose one person moving towards north and one is source, that is listener, moving towards east or west. So the distance between the north and the east or west is 90 degree. So that imagine, so due to this one there is no Doppler effect. Okay students. Okay, and the last one is, if the source is situated at the center of the circle along with the listener is moving. So if the listener moving in an circle, if the listener moving in an circular way, there is no Doppler effect. Okay students, right? So these are the conditions for no Doppler effect. Okay students, so from this one marks will come. What will come? 1 marks. Okay students, right. Applications of Doppler effect. Applications of Doppler effect. Okay, see, there are 4 applications given in our book. So applications of Doppler effect. See, the first one is to measure the speed of an automobile. To measure the speed. How, sir? See, it's very easy. An electromagnetic wave is emitted by a source attached to the police car, right? So the wave is reflected by a moving vehicle which act a moving source. So that moving vehicle act as a source, moving source. Okay, there is a shift in the frequency of reflected wave. So from the frequency shift, so what is shift? Changes, frequency changes. So there is a frequency changes, the speed of the car can be determined. So this helps to track the overspeed vehicles. Yes, we do. If we go to uh, metro cities, and you will see that to find out the speed of the vehicle meters. Okay, okay students. Okay, and next, tracking a satellite. So that is a GPS, global positioning system. Okay, see this, the frequency of radio waves emitted by a satellite decreases as the satellite passes away from the earth. So by measuring the change in the frequency of radio waves and the location of the satellite is situated. So to find out the tracking a satellite, so the satellite tracking systems we are using Doppler effect. Okay, okay students, right. And next, radar. Radar means radio detection and ranging. So radio waves are sent, that is radio pulses, right? Okay, so radio waves are sent and the reflected waves are detected by the receiver of the radar station. From the frequency change, the speed and the location of the aeroplanes and aircrafts are tracked. So radar systems used in mostly in defense purpose. See the applications of radar. Yes, radar applications. There are n number of applications. Yes, see the first one. The Doppler effect is used in some types of radar to measure the speed of detected objects. For example, a police officer uses radar guns to check for speeding vehicles, and the radar gun emitted waves at a particular frequency, which when strikes the vehicle bounce back towards the gun. So the radar gun then measure the frequency of the returning waves and eventually determine the speed. So to find out the speed of the car. Yes, the students, right. Next, another, the Doppler effect is used in medical diagnosis. Yes, medical diagnosis. So the first one, physicians and medical technicians apply Doppler effect to measure the rate and the direction of blood flow in a patient's body along with ultrasound. So with the help of the ultrasound, they find out in the blood circulation, and ultrasound beam are pointed towards an artery and the reflected waves exhibit a shift frequency. So that is a change in frequency. Shift means difference in frequency, because the blood cells are acting as a moving source of sound waves. So which waves? Moving waves. So Doppler effect used in medical diagnosis also. Okay. And next, it is used in satellite communication system. Yes, applications of Doppler effect, satellite communication system. So in satellite communication, satellite employs Doppler effect in its tracking technique for determining distance between satellite and the receiver at the time of closest approach as well as the time itself. Okay. And third one, approaching satellite increases the frequency relative to the S actual transmission frequency. So as it reset at the frequency lowered at the time of closest approach, and usually the same. Okay, so which is used in satellite communication. Okay, students, you don't worry about these points, just this is for additional information. Okay, students, right. And see this continuation. Doppler effect has found it used in several other areas, which includes astronomy and vibration measurements, and to sense gesture, that is computer based, used in audio and velocity profile measurement, etc. So Doppler effect used in these areas. Okay, students, right. The last one is sonar. Which one? Sonar. See, in sonar, by measuring the change in the frequency between the sent signal and receiving signal. Yes, so we are sending the signal from one source, and we are receiving the signals from the same source. There is a frequency change definitely takes place. So the frequency difference only to measure the distance between the source and that any object. Okay, therefore the speed of marine animals and submarines can be determined with the help of sonar. Okay, students, right. So these are the applications. See this. So there is the ship to measure the depth of the sea. So this is the receiver and transmitter. So transmitter just transmit the radio pulses, that is called transmitted pulses to the sea. So definitely what will happen, there is a surface under this sea, therefore that pulses are incident on the surface and reflected. So that reflected wave is reflected pulses. That reflected pulses are received by the receiver. So there is a frequency difference based on that to measure the depth of the sea. Okay, so like this. So these are that systems to measure the depth. Okay, students. Okay, right. And yes, now what is sonar? Sound navigation and ranging. So radar for radio detection and ranging, and now sonar is nothing but sound navigation and ranging. Okay, see this, a sensor that is used to detect object through the use of high or low frequency sound waves. So with help of sound waves they are measuring or detecting the objects. Okay, right. Types of sonar. So there are two types of sonar. One is active sonar, another one is passive sonar. One is active, another one is passive. Okay, students, right. Applications, entire applications. It is used in submarine and mine detections, and is used in commercial fishing and diving safety. So that is used in navy divers, they are using this sonar devices. And communication at sea, and it is used to detect icebergs, and it is used in to measure the water depth and locate sunken ships and other historical objects, right? And to locate the fish or tracked animals that are being is studied. And mapping underwater is features, mapping and underwater features. Okay students, these are that is applications of sonar. Okay students, right? Students, today class is over, that means theoretical side is over. Okay students, so in next class we will discuss 1 marks. Okay students, right? Okay, thank you students, we'll see you on next video. Okay, thank you.